Lesson 4. Cybersecurity and Zero Trust. Zero Trust Security Model. Zero Trust is a security model that assumes no user, device, or system should be trusted by default, even if it is inside the network. The Zero Trust security model addresses some of the limitations of perimeter-based network security strategies by removing the assumption of trust from the equation. Rather than assuming trust based on network location, Zero Trust enforces security controls for every user, device, application, and connection, regardless of where they originate. At its core, Zero Trust operates on the principle, never trust by default. Always verify. Zero Trust core principles. Zero Trust is guided by several foundational principles. 1. No default trust. Users, devices, applications, and traffic are never trusted automatically. 2. Continuous verification. Access decisions are evaluated continuously, not just at login. 3. Least privilege access. Entities are granted only the access necessary to perform authorized tasks. For monitoring and inspection, allowed traffic is continuously inspected for threats and abnormal behavior. Benefits of the Zero Trust model. Improved effectiveness. Improved effectiveness in mitigating data loss with visibility and safe enablement of applications, plus detection and prevention of cyber threats. Greater efficiency. Greater efficiency for achieving and maintaining compliance with security and privacy mandates by using trust boundaries to segment sensitive applications, systems, and data. Support for modern IT environments. Improved ability to securely enable transformative IT initiatives, such as user mobility, bring your own device BYOD, and bring your own access BYOA policies, infrastructure virtualization, and cloud computing. Lower complexity and total cost of ownership. Lower total cost of ownership with a consolidated and fully integrated security operating platform, rather than a disparate array of siloed, purpose-built security point products. Zero Trust architecture in cybersecurity. An architecture describes how security principles are translated into a structure design that guides where controls are placed, how access is enforced, and how systems interact. A Zero Trust architecture is a way of organizing security controls so that verification, access enforcement, and monitoring occur consistently across users, devices, applications, and data, regardless of location. It focuses on protecting what matters most by placing security controls as close as possible to critical resources and continuously enforcing policy based on identity, context, and behavior. Rather than defending a broad network perimeter, Zero Trust architectures are built around smaller, well-defined protection zones that reduce attack paths and limit lateral movement. Review the tab below for more information about the main components of a Zero Trust architecture. Fundamental assertions. There are fundamental assertions about Zero Trust. The network is always assumed to be hostile. External and internal threats exist on the network at all times. Network locality is not sufficient for deciding trust in a network. Every device, user, and network flow is authenticated and authorized. Policies must be dynamic and calculated from as many sources of data as possible. Zero Trust segmentation platform. A Zero Trust segmentation platform defines internal trust boundaries, often referred to as trust zones. A trust zone is a group of systems with similar risk profiles and functionality. Trust zones are not pockets of unrestricted trust. Even traffic between systems within the same zone is inspected and controlled to prevent lateral movement and insider threats. Effective Zero Trust implementations rely on centralized management and monitoring. Traffic logs and session data are collected and analyzed to improve visibility into network behavior, detect unknown or emerging threats, support compliance and audit requirements. Centralized visibility enables consistent policy enforcement across distributed environments. Protect surface versus attack surface. The Zero Trust model identifies a protect surface made up of the network's most critical and valuable data, assets, applications, and services. DAS. Protect surfaces are unique to each organization. Because the protect surface contains only what's most critical to an organization's operations. The protect surface is orders of magnitude smaller than the attack surface and always defined. Zero Trust Least Privilege Access Model. Zero Trust enforces least privilege access, meaning users and devices receive only the access required to perform authorized tasks. Click the tabs for more information about Zero Trust Least Privilege Access Model. Maintain visibility of and control over the applications and their functionality. Traditional security infrastructure describes applications through ports and protocols. Zero Trust's least privilege access model requires precise control over application use, which a port and protocol definition cannot achieve. Allow specific applications and block everything else, allowing a specific set of applications through an allow list and denying everything else significantly reduces the number of ways an organization can be attacked. Dynamically define access to sensitive applications and data based on a user's group membership. Many traditional security policies define access based on the location of the endpoint in the network. Even if enterprise mobility didn't blur the traditional network boundaries, network location is a poor identifier for a user and their assigned privileges. Dynamically define access from devices or device groups to sensitive applications and data, or from users and user groups to specific devices. This is important in IoT-heavy environments, where devices may access applications and data in the same way a user would. For example, medical equipment may be sending sensitive data to specific applications or repositories. Validate a user's identity through authentication for access to the most sensitive data. The firewall validates user information obtained from the organization's authentication servers with another authentication method before allowing access. This ensures the traffic is coming from the expected user and not from someone impersonating them. Dynamically define the resources that are associated with the sensitive data or application. Many data centers and platform as a service pass environments dynamically allocate resources to applications to ensure that the security posture matches the current resource allocation. The firewall needs to adjust along with the changing environment. Control data by file type and content. Blocking risky file types reduces the number of ways an environment can be attacked and reduces the number of ways attackers can exfiltrate data.